Welcome to clickmyproject.com. Let me discuss about the process human biometric identification through integration of footprint and gait. Let me see the abstract of the process. Recognition of human from gait and footprint were helpful in security purposes. Recognition of the persons is not a matter for human visual system. The identification of the persons by the system needs some special mechanisms. The identification of the persons by the systems will be helpful in computer vision process. Recognizing the persons using the feature values extracted from footprint and gait is more reliable since the footprint of the same persons have same patterns. These processes were very easy to implement and they were reliable all the time. The gait of the persons were also more reliable in the identification of the individual persons. Gait recognition is the systematic study of locomotion, more specifically the study of human motion using the eye and the brain of the observers, augmented by instrumentation for measuring body movements, body mechanics, and the activity of the muscles. Gait analysis is used to access, plan, and treat individuals with conditions affecting their stability to ability to walk. It is also commonly used in sports biomechanics to help athletes more efficiently and to identify posture-related or movement-related problems in people with injuries. The study encompasses qualification, that is, introduction and analysis of the measurable parameters of the gaits, as well as the interpretation, that is, drawing various conclusions about the persons from its gait patterns. The gait sequences were used for the authentication of the person. The gait energy images on the footprint of the individuals were collected. The collected gait energy images and the footprints were trained by extracted the feature values by labeling of the individuals. Pre-processing is done by median filter. Features were extracted from the pre-processed images. LDA and PCA were employed to extract the feature values from the images. The features were then classified using equivalent distance measures. The classifiers gives the labels corresponding to the input features. The persons were recognized based on the labels written by the classifier. The performance of the process is measured by employing only gait for recognition and then footprint alone for recognition. The combination of the gait and the footprint are proved to produce better recognition rate in all the cases. In most of the cases, the combination of the biometric can possibly improve the performances of the recognition process. Since the advantages of one biometric can be overcome by the another biometric, the correct classification rate is measured in order to measure the performance of the process. The process is tested with different training samples and the results shows that the correct classification rate is high for the combination of gait and footprint compared to the identification using gait and footprint alone. Let me see the flow of the process. First, the test images were selected. Here, the test images refers to the gait and the footprint. So, if we want to use the recognition based on footprint alone, means first the footprint is selected, else the gait is alone selected, or else when combined means both footprint and gait images were selected. So after the test images has been selected, pre-processing step is employed. So in the pre-processing step, basic gray conversion processes and the noise removing processes were employed. For noise removing, median filter were employed. After that, the features were extracted from the images based on PCA and LDA features. The PCA and the LDA features were used for the extraction of the features from the images. After the extraction of the features, the collected values were analyzed, combined and saved as the test feature values. So if we want to recognize with gait alone means the gait features were alone taken as the test features, and footprint means they alone taken as the test features, or else they were combined and they were taken as the test features. The same processes were repeated for all the images in the databases. So this is the training processes. So all the same procedures were repeated as it is. So first all the pre-processing steps and the feature extraction steps all were repeated as it is, and the extracted values were saved as the trained feature values. So for gate, footprint, and combined gate and footprint, so these values were all executed, and then based on the recognition processes, the classification methodologies were used for the recognition of the gates based on the labels provided to the classifiers. So after recognition, the overall performances of the process is measured in terms of the performance matrices like accuracy, sensitivity, like that. Let me see the running procedure of the process. Select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user. When we click on footprint alone, the this user face will be open, so we can give any one of the footprint here. Then we apply pre-processing process. We are extracting this feature values from this footprint obtained. Then we perform the recognition process. So this footprint corresponds to person, and then finally we measure the performance. So totally we have trained with 200 samples. So as for complete samples, the recognition rate will be 90%. So as we can change the number of training samples, so and based on this the correct classification rate will be obtained. Then we move on to the gate recognition. The performance for measuring a gate alone is 96%. So as we change the values training samples, so the correct classification rate differs. Then we measure the performance for both footprint and gate. So we select any one of the gate, so corresponding footprint will be retrieved directly. Then we apply the pre-processing process. Then the features were extracted for those footprint and the gate. Then we apply the recognition process. So this person is recognized the second person. So finally we are measuring. So the recognition will be 97. If we want to change the number of training samples means we can change, and we can see that number of correct classification rate for those number of training samples. Then after that we are the correct classification rate for different experiments. That is, we are measuring the correct classification rate for different number of training samples for classification using footprint alone, gate alone, and combining both footprint and gate. So as we can see, those values differ, and overall we can obtain nearly in footprint process nearly 90%. So in gate process nearly 96%, and in gate process nearly 96%. So this is the process. Thank you.